Welcome. In this session, we'll be diving into the process of creating a very simple software bill of material, or BOM. And by using just the BOM, we'll be able to identify vulnerabilities as well as outdated components. Now, there are two competing ways to identify vulnerabilities in third-party and open-source components. The first is to perform a scan against the files themselves. It's the most common approach, it's instantly gratifying, it's valuable, and then it works. Some tools are ecosystem specific, for example, NPM Audit, .NET Retire, PHP Security Checker. These things are all specific to different ecosystems. The second way is to simply create or acquire a BOM and then use that to perform your analysis. A BOM is simply a list of all your dependencies, including transitive, along with a bunch of metadata describing what those dependencies are. It's a much simpler approach, it's a much cleaner approach that has numerous development, security, compliance, regulatory, and economic advantages. There isn't a right or wrong way to identify risky components. The only wrong way is to do nothing at all. But there are many advantages to a BOM-based approach that you simply don't get with other methods. So in this session, we'll be exploring the power of the BOM. I'm going to show a fully automated, everything integrated way of doing this, but I want to start off by doing it manually first, just to show how easy it is. So the project I'm working on just so happens to be a Node.js project, but the same approach could be taken for .NET, Java, Python, etc. First thing I'm going to do is create a BOM, specifically a CycloneDX BOM. Now, CycloneDX is a very lightweight bill of material specification that has an application security focus. Then I'm going to upload the BOM to a project that I've defined in Dependency-Track already. And that's it. It's really two steps. That's everything that's required. Now, Dependency-Track will now display all of my direct and transitive dependencies for my project, as well as indicate if those dependencies are out of date. And of course, it's going to provide a list of all the vulnerabilities that have been identified along the way. And it will keep on updating this information every 24 hours or after every new BOM has been uploaded. It really is that simple. But we don't want to do things manually. We do want to strive for automation when possible. So I'm going to switch over to Jenkins. And I have an existing Jenkins job configured already, but the first thing I want to do is add an additional build step to create that CycloneDX BOM, and this will actually be written out to the current working directory. And now that that's done, we will add a post build step and specify the project that I want the BOM uploaded to. Now I'm going to enable synchronous publishing mode. This mode will wait for the BOM to be processed and retrieve the results when complete. The Jenkins job may take a tad bit longer, but I get the benefit of having historical trends, per build findings that also incorporate analysis decisions and all kinds of other things, and we'll demonstrate that in a bit. So at this point, I'm going to save the job and run it. While we're waiting for this job to complete, it should be pointed out that the Jenkins server, it isn't doing any scanning. The job is configured to offload the analysis of the BOM to Dependency-Track. We're just simply waiting for the results. And the results are in. Now, for the sake of demonstration purposes, suppose my organization's security team has marked one of the findings as not applicable, or maybe another finding as being exploitable. And just to show what we're talking about, let's change the states of the first two findings here to demonstrate. The process of triaging findings actually creates an audit trail, which includes analysis decisions, comments, suppressions, and of course timestamps for when all these events occurred. But now that we've identified and modified these two findings, let's run that Jenkins job again and compare the results. As you can see, the findings that were marked as not applicable and then suppressed are no longer present in my results. And the finding that was marked exploitable is now indicated as such in my Jenkins findings. Now, this is powerful stuff. Super simple, yet very effective way to create a complete bill of material, automate the uploading and analysis of the BOM, and provide a continuous feedback loop between my development organization and my security team. This is the power of the BOM.